Welcome back, friends. Unit 4, Lesson 7. I missed you. Let's do some log stuff. All right? So I actually have two students in the classroom that are going to try to maintain some sort of silence during this video. It would be awesome to see if they can do it. They may not. Would you guys like to say hello?
Hi.
Oh, yeah. I won't tell you who that was, but yeah, that's okay. So we are going to be talking about logs. I like logs. Logs are fun. They're good. Look at his face, though. Isn't he so sad? This guy's much better. I like using natural log a million times better when I can, for one main reason. If I write log, that's 3 letters. If I write ln, it's 2. You know, mathematicians don't like to write as much. So I like using natural log, not only for that reason, but the number e, and yes, I said the number e, comes into play. That's where this little pun comes from, natural e, because natural log deals with the number e so much nicer. And actually, log and natural log will perform the same operations, just to different bases. You'll see the little statement that log is making here. It says, people have 10 fingers and 10 toes, and it makes sense to use a base 10, because this little fella here has a base 10 to whatever he's taking the log of. Natural log has a base e, all right? Yeah, that's important, but not so important, but important. Let's just move forward and start to plug and play. One of the most basic things, excuse me, about logs and logarithmic functions that you need to understand is it's really just dealing with exponents. What do I mean? Okay, let me give you an exponent equation, meaning I can say 5 squared, well, that equals 25. I think we're all comfortable with that, okay? If I want to write that in log form, okay, I say the log, okay, and all I do is really switch my 2 and my 25. Log of 5, 25. You see how it looks like the 25 is the exponent, the 5 is lower, okay? That equals 2. So what is log really doing? Log is really saying, if I put 5 to an exponent, I would get 25. What is that exponent that makes that work? Okay? So log can just say, like, what exponent, what power of 5 gives you 25? And the answer, of course, is 2, because we know 5 squared is 25. All right? Now, back in the day, years ago, I taught a girl. Her name was Mahagony Holmes. And every year I teach this, I mention her name. And she struggled with math, but for some reason, logs, people don't like them. I would just rather work with exponents, like on the left side here. But she knocked the test out the park, okay? And I asked her, I'm like, man, how did you get that so well? And she said, well, what I told you here isn't my thing. That's what she just came up with, which I guess makes sense. She would always say, the log of 749 equals what? She would know. You can drop the log just by switching these two values. 7 to what power is 49? Well, she would know that's 2. Okay, same thing. Let's go someplace else. Log base 3 of x equals 81. And again, she would drop the log and just switch these two and say, oh, yeah, that's really big. I should make that. I wouldn't expect you guys to do that. 4, okay? And she would just switch those. And she would say 3 to the power of 4 would equal what? Well, she knows 3 to the 4th power is 81. And she would do that, and she did really well. And now, every time I teach this, switching those two values, I just call mahagonize. You need to mahagonize it. The Mahagony Theorem. Okay, that made her feel good, and she did better the rest of the year because I kind of acknowledged that, you know, and it made her feel good, and it made her feel like she can do well in math, okay? So if you hear me say mahagonize, I am just switching the two values. I'm literally switching the two values to have log. I can switch them to drop the log like we did here, or I could switch them to bring the log back in, okay? It goes both ways. It's really quite brilliant. So now that we have a brief little background about what log is, what it does, what it pertains to, exponents. And I showed you how to mahagonize some things here. Oh my God, look at the second example. It's the one I use. What are the odds? Let's do a couple of these things, okay? There are two ways in which you would have to evaluate a log by itself. The first one, they would actually give you these two numbers. This is called the base, okay? Log base 8 of 32 equals what? I would just type that right in the calculator. The calculator has a log base function, okay? So that's just a type into calculator. You can switch those, okay? But then you're going to have to use log to undo them. So I would just type that right into the calculator, all right? And that is at math, and I believe it's option A. There are two ways to get there. You can hit math, then I believe it's A, or I hit alpha window. That's my, alpha's the green button, then window. And it's listed right there under shortcuts. That's the way I prefer. Either way is better. Well, either way is good. I think my way is better, but you might think the math A way is better. What do I mean? Okay, let's take a look at here. I'm going to hit the math button first. Boom, right there. Bang. And if I scroll down, I got to scroll all the way down to A. Right there, log base. I can do that when I hit enter. There it is. I put my base 8 of 32. Hit enter. And it gives me a decimal. You should, at this point in your mathematical careers, give fractions, okay? And how do we turn a decimal into fractions? Math, enter, enter. Math again, enter, enter. And the answer is 5/3, all right? So that's our answer. Now, Mr. Visca said there was a second way, alpha window. You know, if I hit alpha y equals, that's how I can put a fraction in. Well, if I hit alpha window, right there, log base. And then for calculus, we have these two shortcuts there. We have absolute value summation, which, did we do that already? We did at the beginning part of this unit. So there's a lot of relevant stuff there. Alpha window. And I'm going to pick number 5 for log base. It's the same thing. Okay, so we know that answer, x should be 5/3 based on the calculator. Now, the second one, I'm going to mahagonize this. Oh, thank you, Mahagony Holmes. I'm going to switch my x and my 4, and I'm going to have 3 to the power 4 equals x, and the log goes bye-bye. Well, that's 3 times 3 times 3 times 3. This is 9 times 9, which we all know is 81. And if you want to check that in a calculator, you could simply say log base 3 of 81. I would absolutely 110% check everything that I did with my paper and pencil or in my head, especially on a final. You don't want to lose points. Log base 3 of 81, we said. That should be 4, shouldn't it? And there it is. Okay. Not bad. It seems to be okay. Well, you know we step it up, but feel comfortable with what you know right now. Okay, lightning round. All right, I am going to do these somewhat quickly, and I would like you, I would probably pause this video and see if you can do them on your own, and then after you do them, unpause it and see if you get the right answer. First, I would just like to point out for number 5. Actually, I would like to point out for the whole bottom row, you notice there's bases that aren't written. Based on that picture that was in the beginning of the notes, this one right here. All right, what do we say? Log had a base 10 if it's not written. If there is no number here, it's assumed that's a base 10. Same thing with E. If there is no base written, it's assumed that it's the number E. Okay, so let's go back. All right. And let me explain. This is the same thing as saying natural log base E of x equals 4. This one right here, see there's no base? That's like log base 10 of 1,000 equals x, and so forth. Now, the good thing in the calculator is if there's no base written, you don't have to type a base in. There's a ln button that will just do this for you, where you don't have to type the base in. There's a log button. You don't have to use log base, where you can just put that in. Okay? So let's move forward and do these things right now. Okay. That's 8 squared equals x, because I switched these two. X equals 64. Okay, beautiful. I switch these two here. There's a 4 to the x equals 2. Well, I know it's the square root of 4, and square root as a fraction is 1/2. So 1/2 equals x. I can also put this right in the calculator and hit enter, and I would get 1/2. In fact, that's how you should do it. Okay. The next one. All right, well, I got x. I'm going to switch these two. Squared equals 16. In order to solve that, I take the square root, and x would equal 4. Okay. Point to note. Okay. If I take log base of 4 and put a 16 here, because that's what we got as an answer, it is 2. Because some of you might say, shouldn't this be plus or minus 4 when we take the square root of something squared? Well, let's check negative 4. I'm going to hit alpha, window, 5. Okay, I'm going to say negative 4 of 16. I get an error. It says a non-real answer. Why? If I hit go to, this is going to put my little cursor next to the log. I cannot have a negative number for my base. You cannot have a negative number for the base. I wonder if we put a 0 there. Let's put a 0. See if we can. I think it might have to be positive, but let's put 0 there and see what happens. I get an error as well. It has to be bigger than 0. Your base has to be bigger than 0. So when I come over here and I look at this and I get 2 answers, I should say, hey, I'm looking for a base. I know I can't have negative values, so it's only positive 4. All right. Next one. Let's swap these two. 2 to the x equals 8. You, of course, should be able to just put that in the calculator and enter, and you would get x equals 3, because 2 cubed is 8. All right. Now these ones here, I am absolutely going to put this in the calculator. Okay. We have a base. Let's clear this out. Clear. The ln button, in case you didn't know, is right next to the number 4 here. Right there. The ln of x equals 4. All right. So clear this out. I just want to show that to you. We said this is ln of e to the x equals 4. I can still mahagonize this, meaning e to the power of 4 equals x. Now, I would accept that as an answer, but if this is multiple choice, you might have 4 decimals. How come decimals? E is irrational, just like pi. You cannot represent it with a fraction. When you get to calculus, your answers need to be left like this. Okay? But because we can put e in the calculator, e is in 2 spots. Above ln in blue, you'll see e to the x, and I'll just put a 4 there. It's 54.598. Let's call it 54.6. So that's approximately, x is approximately 54.6. Okay. This is a log base 10. All right, I would put this in the calculator, and x should equal 3, because 10 cubed is 1,000. Okay, this is log base 10. All right, so I'm going to say if I drop the log and I switch these two, 10 to the negative 2 equals x. We know how to handle negative exponents. We flip them, right? So it's 1 over 10, and now my 2 exponent becomes positive, which is 1 over 100th, which is 1/100th, 1 over 100. Bam, very good, very good. All right, this one here, okay? I'm going to switch my 8 and my 3 halves. So we got x to the 3 halves equals 8. We just did work like this a lesson or two ago. How do I get rid of a rational exponent? I raise it to the reciprocal. 2/3. That means I put this to the 2/3. These go by x equals, the cubed root of 8 is 2, and if I square 2, I get 4. And there you go. Okay, so we have some properties. We just learned these exponent properties a lesson or two ago. And if exponents have properties, shouldn't logs also have properties? Because logs deal with exponents, and they do. All right, so let me go through these one at a time. And just like I can go back and forth, I can go back and forth with these log properties, meaning if I am taking, all right, the log of some base m, I should call that base b because they use m and n's here. So log base b, whatever it is, of m times n. Doesn't multiplication turn into addition? Well, guess what? That's like saying the log base b of m plus the log base b of n. Okay, so if I see this where I'm adding two things, I can put them together in one log and multiply them. Okay, let's do the next one. Okay, if I'm taking the log, I'll start with the expanded version first. Base b of m minus log base b of n. Well, that's like dividing them because subtraction and division tend to go together. M over n. I can put that, that's a very bad n. I can put that in one log and just divide them. Just like these two right here, if I'm adding them, I can put them in one log and multiply them. All right, this next one comes in handy. I'm going to tell you that right now. If I'm taking the log base b of m raised to the n, okay? If that m has an exponent, that exponent, like if I have an exponent raised to an exponent here, don't I just multiply? So this n can come down and become a lead coefficient to multiply. N times log base b of m. That's a nice one to know, especially if that n is a variable. I can pull that down and solve for it a lot easier. Okay, so just by applying log, I can bring exponents down, and that becomes a big thing. This one right here, which of course I mean the log version of it, that becomes a big thing in solving for variables that are in the exponent. All right, here we go. Next one right here. This is more of an in case you forgot. Anything with a rational exponent can be written as a radical. So if I have the log base b of m to the third root of m squared, that's the same thing as saying log base b of m to the 2/3, right? That's an exponent. And what can we do with exponents? Bring them out front. It's kind of the same thing we just did for the previous step, except now it's a radical that can be turned into an exponent that's a fraction, which can be brought out front. Okay? Oh, these next two, I love them. I love them so much. Right? Anything to the power of 1 is itself, right? So if I take the log, let me pause this. The board is starting to get off. Okay, we're back. So anything to the power of 1 is itself. So if I take the log of some base b of b, where the logs are the same, it has to be 1. Okay? If these two are the same, it's 1. Now, same thing goes for ln. ln, but the base of ln is e. So anytime we take the natural log of e, it's always equal to 1. This is a big one in calculus, and here as well in algebra 2. And last but not least, anything to the power of 0 is 1. So if I take the log of any base, and what exponent makes it equal to 1? 0. Same thing for ln. If I put a 1 right here, it's 0. Of course, that's a base e. Okay, so the log and ln, if I got rid of the bases, it doesn't matter where the bases are. The log and ln of 1 is 0. Okay, up here, the log where the base matches what you're taking the log of, and the ln of e, because that matches the base, it's always 1. So, highlighter, highlighter. Another. If these are the same, it's 1. Look at that, they're the same. It's 1. If I take the log or the natural log of 1, it's 0. Okay? And down here, it's just, it talks more about e. ln e of x equals the ln of x, because e is our base. We don't have to write e. Okay? And log 10, if it's 10, you don't have to write the 10 here. If it's anything other than 10, they will write it there for you. Okay, let's do some problems here and see what's happening. We are going to expand these out. Right now we have 1 log. I'm going to expand these out. What's my rule if I'm multiplying them? I can turn them into addition. It's x plus the log base 5 of y. If I'm multiplying these two, I can expand them out into addition. All right, the next one, number 2, ln, big whoop-de-doo. ln is a log. The same rules apply to it. I am multiplying x cubed. Wow, that's weird. I am multiplying x cubed times y. So it's the ln of x cubed plus the ln of y. But what's my rule about exponents? Don't they come out front? So it's 3 times ln of x plus ln of y. Good. And my board is starting to stroke out. It's been doing so good so far. Number 3. Okay. Wow, look at that. I'm doing a straight line. It is like a heartbeat. There you go. Weird. Weird. It's stroking out. Okay, so anyways, division turns to subtraction. So it's log, wow, base 3 of 2 minus log base 3 of z, wow, to the 4th. Wow. I'm going to keep on going because this is entertaining to me. All right, here we go. So this stays the same, log base 3 of 2 minus exponent comes down 4 times the log, wow, base 3 of z. Man, my 2's and z's look the same, my 3, base 3 of z, and this is the number 2. Wowzers, wow. How many times can I say wow? Have I said it enough? Wow. How about this? Wow, this board sucks. All right, let me recalibrate it. Hopefully that's better. Okay, it is not. The ln, oh my goodness, of 5 times radical k, that's like saying k to the 1/2 power. Okay? So now I've got ln of 5 plus ln of k to the 1/2, and my exponent comes out front. So I've got the ln of 5 plus 1/2 ln of k. Wow. Wow. All right. The next two, I've got, okay, it's division. So it's top minus the bottom. So it's the log, not ln. I'm all disheveled because this board has got me going. Okay, it's the log base n of 3x minus log base n of 5 times, I'm going to call that y to the 1/2 because that's square root, right? So I see 2 multiplications. I need to spread them out into additions, okay? But keep in mind, I'm subtracting this whole log thing, okay? So that subtraction is going to have to apply to everything after it. So we've got the log base n of 3 plus the log base n of x minus, okay, the log base n of 5 plus the exponent comes down, right? 1/2 log base n of y. There you go. And if I wanted to, I could distribute that negative sign and make this negative log negative 1/2 log of n, log n of y. Wow. The more you do these, the more you recognize the properties. I mean, I'm writing out every step, but you won't have to soon. Okay. Log of 10 minus, because it's division, log of yz all to the power of 4, which means this 4 is going to come out front. Didn't we just learn what log of 10 was? That's 1. Minus 4 log of yz. Okay? Well, yz is multiplication. That will turn into addition. So I've got 1 minus 4. All right? I got to subtract everything. Log of y plus log of z. In fact, my 4 should get multiplied to both of these. So the way I should write that is my 4 should get multiplied to both log y and log z. And if I wanted to do that, say 1 minus 4 log y minus 4 log z. So I can distribute my minus 4. Woo! One more thing and then we're going to be done. That's a lot of stroking out there. Now, just like we broke things apart, we're going to condense them and put them back together. Okay? This first one, subtraction, goes back to division. So it's log base m of 24 divided by 6. And we know 24 divided by 6 is just 4. Bam. 2. Okay. Read coefficients become exponents again. So this is going to be log base 2 of x cubed. And when I add, that goes back to multiplication. So now I've got log squared of x cubed times y. It really is that simple. I'm going to go through these rather quickly. That's okay. 2 becomes 5 squared. 1/2 becomes 4 to the 1/2. When I add, that turns to multiplication. So I've got log of 5 squared times anything to the 1/2 power is square root. Done. Ooh, love this. This 2 becomes an exponent for both of these. Okay, ln of e, well, that's just 1. So I've got the ln of 2e squared, and I guess minus 1. Okay, I wanted to break that off. I guess that's it. But I wanted to break this off because it's multiplication. I wanted to expand it to make it addition, but we are trying to put it back together. So, I mean, I guess I could say 4e squared if I wanted to, but I'm not going to. I'm going to leave that just like that. Yeah, that was an easy one. That was easier than it appeared to be. All right, good. Exponent, 1/3. Exponent, 3. That's it. Okay. Ooh, nasty. Now, I'm going to take, all right, notice I am subtracting both of these from y. So I'm just going to say that's like log c of y minus log of z cubed of c, okay, plus, because I'm factoring out the negative, log c of y to the 1/3, okay? Now, I know I've got, this will turn into division, so I've got the log base c of some division. Here's the top. And this turns into multiplication because of the addition on the bottom, okay? Z cubed, and that is the cubed root of y. That is what you should have come up with. That's not bad, and we're done. And holy smokes, 29 minutes. I have 10 seconds to say goodbye and that I love you. I'm not going to this time. It gets weird when I do it too many times. But, you know, see you later. Save.